We're back with the series connection, and in this video we want to work out a mathematical example. We have an electric circuit that represents a series connection, and that circuit consists of 4 resistors and a voltage source. The resistances are labeled beneath each resistor, and the source voltage is 28 volts. And we are looking for the total resistance, the current, the voltage drops across the individual resistors, and the electric power. And to compute these values, we will be using Ohm's law and the general laws pertaining to a series connection. So let's get started with the total resistance. As you have learned in the previous video, the total resistance in a series connection is equal to the sum of all individual resistances. So R tot is equal to the sum of all Ri's in the series connection. And in our case, computing the sum requires us to add R1, R2, R3, and R4 together, and that gives us 130 ohms. Ohm is the unit of electric resistance. And now that we have found the total resistance, we can go on and compute the current that flows through all resistors. And to compute the current, we will be using this equation, R is equal to U divided by R. So I, the electric current, is equal to the source voltage in our case, because we are computing the current that flows through all components, through all resistors. So that's the source voltage divided by the total resistance. And we have 28 volts divided by 130 ohms, and that is equal to 0.21215 amps or ampere, and we're gonna round it up to 2 decimal places. That is 0.22 amps. We have rounded this up because that will make it easier to perform the upcoming calculations. Now, the voltage drops across each individual resistor. The equation to compute them is here. U is equal to I times R. For U1, the voltage drop across the resistor R1 is equal to the product of the current and the resistance R1. That's equal to 0.22 amps times 20 ohms, and that's equal to 4.4 volts. This is the voltage drop across the resistor R1. We're going to perform the same calculation for the other resistors or the other voltage drops. I'm just going to write down the result directly because I don't want to make this video too long. Multiplying I by R2 yields 8.8 volts. And then U3, which is I times R3, is equal to 13.2 volts. And U4 is I times R4 which is equal to 2.2 volts. I'm gonna underline the values to make them stand out. So we have computed the voltage drops across each individual resistor. And now the only variable that is unknown is the electric power. And the electric power can be computed as the product of voltage and current. Now, the voltage is going to be the source voltage, because we're looking for the power dissipated by the whole circuit. And we need to use the source voltage as the voltage, so it's going to be US times I, the current, which, as you know, is constant everywhere in the circuit. And US is 28 volts, then times 0.22 amps, and that is equal to 6.16 watt. Watt is the unit of electric power. Not just electric power, but power in general. So this is how you perform calculations on variables related to series connection. You first check what values are given, and then you check what values are you looking for, and then you apply Ohm's law, or the equations related to Ohm's law, to find the values that you are looking for. And once you have found the first unknown value, in the next step, you will probably have to use that value to find the next value, like we did with finding the total resistance first, and that gave us the opportunity to find the current flowing through each resistor. So much about the series connection. In the next video, we're going to start talking about the parallel connection. Until then, I'm going to say so long and good luck.